Unit 2, Lesson 9. We are, I believe, solving for variables. This is day 2 of that lesson. Mr. Wilson taught that lesson yesterday. I'm teaching the back half of it today. And so let's just jump right in. Okay, the perimeter of a rectangle is 48 centimeters. The relationship between the length, the width, the perimeter of the rectangle. All right, we can see that. Okay, you guys all know that 2L plus 2W equals the perimeter. And in this case, it is 48. Okay, so we need to find the length in centimeters if the width is x centimeters. Okay, so in other words, we are solving for this. Okay, so now to get this, remember we're going to isolate the variables. So we're going to use our inverse operations. We're going to subtract 2L from both sides. Then when I rewrite it, we'll go ahead and put that as x since we know that that's the width it tells us. And I can't subtract 2 from 48 because these are not like terms. Remember, I got to have same variable, same exponent. There is no L with the 48, so I cannot subtract it. So it's 48 minus 2L. Now, to isolate my variable x, I'm going to use the inverse operation and divide by 2. Okay, and then that is my equation. Now, you could leave it like that, or you could write x equals and see how all of these are divisible by 2. Okay, and that would be 24 minus L. But so let's go ahead and we will write in there 48 minus 2L, okay, over 2. Okay, and so that is what we are going to have. And it doesn't have an L in there, and so that is why that wasn't in there. Okay, now in this in this earlier lesson, you saw we looked at these, and it's V plus F minus 2 equals E, which relates the number of vertices, faces, and edges in a Platonic solid. Write the equation that makes it easier to find the number of vertices in an octahedron shown here, which has 8 faces. Okay, so if we know, guys, this is our equation, V plus F minus 2 equals E. Okay, that is what we have. Now, it says that we have 8 faces, so what I can do is I can input an 8 into that F. So now I'm going to have V plus 8 minus 2 equals E. Well, what is 8 minus 2? It's 6. So now I've got V plus 6 equals E. Now we've got to make it easier here, and you see that it is V. So isolate the variable, move the 6 over, V equals E minus 6. Okay? All right. I look at the next equation. Okay, we got the same equation. Now, guys, it's telling us we want to make it easier to find the number of vertices, which is here, vertices, which is there, if I have 30 edges. 30 edges. So now instead of plugging an 8 in for F, we're going to plug a 30 in for E and then solve. So I have V plus F minus 2 equals 30. So now we're going to combine like terms. I'm going to put the 2 over. I'm going to add because it's the inverse operation. Okay, so now I'm going to have V plus F equals 30 plus that is 32. Move your F over using inverse operations. You're going to get tired of me saying that, are you? Inverse operations, and that is what I have, 32 minus F. Okay, now we've got a buckyball. It has 60 vertices. Okay, 60 vertices. And it's telling here, what about the number of faces? So I plug a 60 in for the V. Okay, because again, this is what I have. V plus F minus 2 equals E. I can plug a 60. I can plug a 60 in for V. 60 plus F minus 2 equals E. Now here, guys, combine your like terms. I got a -2 and a 60. That's going to give me 58 plus F equals E. Now we're making it easier to find the number of faces, so I move the 58 over, and now I have F equals E minus 58. Okay, so E minus 58. Wonderful, wonderful, wonderful. All right, let's talk about some automobiles, shall we? Okay, you got a shipment of cars and trucks on a cargo ship that can carry 21,600 tons. Car weighs 3.6, a truck weighs 7.9, or 7.5, I'm sorry. So, guys, let's talk about what we know, okay? So we know the total is 21,600. We know that a car is 3.6. We know that a truck is 7.5. Okay? It says let Y be the number of cars. Let X be the number of trucks. Okay, so guys, they've given us this. So now, hey, to get a total, what would we do? Well, we would add the number of cars that we had with the number of trucks. It's very simple, yeah? So that means, guys, you're going to take the weight of a car times however many you have plus the weight of a truck times however many you have. And if you did that, you would get the total. And guys, that really is all that it is. So 3.6y plus 7.5x equals 21,600. Okay, that is all you have to do. So now, guys, we're going to use that same equation, okay? Even though the trucks are bulkier than cars, a shipment must consist of all trucks as long as it's within the weight limit. Find the number of cars that can be shipped if the cargo already has 480 trucks. So guys, this is the equation that we use. So now it's saying, how many cars could I have if I already know I have 480 trucks? So I'm going to write here, hey, the number of cars is unknown, all right, is unknown. And let me just make sure, guys, did I write that wrong? Yes, I did on my paper here, okay? I meant to write this should be a Y and this should be an X. I apologize. I did it right on the other one, but Y is the car and X is the truck. Okay, just making sure that we have that. Okay, so guys, now I come here and I say, okay, how many, find the number of cars that can be shipped if the cargo already has 480 trucks. So I'm going to come over here. The car now is unknown plus the 7.5. Now we already know that there is 480 trucks, and that's going to equal this. So our first step is to multiply 7.5 times 480. So 7.5 times 480. I get 3,600. So now I'm going to have 3.6y, okay, plus 3,600 equals 21,600. Okay, here's my new equation. Now your next step, okay, you got to move this over because, again, we're trying to isolate the variable. And I'm going to get 3.6y equals, okay, equals 1,800. All right. Now we're going to divide to isolate the variable using the inverse operation. And I'm going to have 1,800 divided by 3.6, and it's 500, okay? So then that means that y equals 500, so it is 500 cars. 500 cars. Okay? There we go. All right. Perfect, 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 guys. So that means that we're going to have those there. All right. I love it. Okay? All right. Okay. An automobile manufacturer is preparing a shipment of cars and trucks. Again, okay, so we're using this. All right, let's make sure that, let's write this again. Okay, it was, the total was 21,600. Okay, we have our cars as 3.6. Our truck is a 7.5. We wanted to say that this was Y and this was X for shipment. Okay, find the number of cars that can be shipped if they're already. So, okay, so the last question, guys, we did this if there was already 480 trucks. So now we're going to say, what if there is 1,500 trucks? Okay, 1,500 trucks. All right. So now we're going to write this equation. Okay, I've got 3.6y plus 7.5x equals 21,600, and it's saying that we have 1,500 trucks. Okay, so now we're going to take a 3.6y plus 7.5 times 1,500 equals 21,600. Okay, now I'm going to take that 7.5 times 1,500. Okay, so now that's going to give me a 3.6y plus 11,250 equals, oops, sorry, 21,600. Okay, now what is our next step? We're going to subtract 11,250. That's going to equal 3.6y equals, okay, and let's go ahead and subtract this. So it was 21,600 minus 11,250, and you see that we have 103.50. Okay? So now, guys, this is my new equation. Divide by 3.6. Okay? Divide that by 3.6. And I am going to get 2,875 cars. Okay, 2,875 cars. And you know, now that we're doing that, let's go back, okay? So when we did this, guys, and I said 500, could I have made a mistake on this? And I did, okay? Let's look at my mistake, guys. When I did this, notice what happened. I accidentally didn't put another 0, did I? I should have had another 0 right here. In doing so, shouldn't we have had 5,000 cars? Hey, there we go, 5,000 cars. Now, doesn't that look a lot better? All right, that was a good catch. I'm glad we caught that and we didn't get too far ahead. Okay, let's look. Okay, find the number of cars that can be shipped if the cargo already has 2,736 trucks. So again, guys, 3.6y plus 7.5. Now we know that the trucks is 2,736. Okay, and that equals 21,600. Okay, take that 7.5 again, and we're going to multiply that, guys, times 2736, and I get 205. So your new equation should be 3.6y plus 2520 equals 2160. All right, here's my new equation. Similar to what we've done, you move it over. I move it over. Okay, so now I'm going to take that 21,600 and I'm going to subtract the 2520. Okay, and I get 1080. 1080. So now I'm going to have 3.6y equals 1080. Divide that by 3.6. Okay. Oh, sorry. I swiped on the wrong spot. Now we got to go all the way back. Okay, where were we at? We were right here. All right. Divide that by 3.6. And I get 300. 300. Okay. All right. 300. That is correct. All right. Now we're going to find it, guys. We're going to make this all together. If the number of cars that can be shipped to the cargo already has X trucks. Okay. So, guys, that means I'm here. 3.6y plus 7.5x equals 21,600. I'm solving for x, right? I'm solving for x, so the first thing I need to do is to move this 3.6y over. How do I do that? By subtracting. So now I've got 7.5x equals, because we're solving for x, okay? So, oh, I'm sorry, I'm solving for x. Guys, let's back up. Let's back up. I need to find the number of cars. I need to find the number of cars. So, scratch that. We've got this, 3.6y plus 7.5x equals 21,600. Okay, and I need to find the number of cars. So, we're going to isolate y. That's going to be my number of cars. So, again, guys, think about what we did first up here. So the first thing we did was we multiplied these together, and then we moved it over. So you subtracted 7.5x. So now I've got 3.6y equals 21,600 minus 7.5x. Now we want to know how many cars there are, so we take and we divide by 3.6. So now that means y equals 21,600 minus 7.5x all over 3.6. Okay, so that's going to be the 21,600. And let's put parentheses around this so we know 21,600. Okay, minus 7.5x all divided by 3.6. All right. Okay. So, guys, we've hit that. Okay, let's move on to the next scenario. Okay, the streets and staffing. So, all right. So the Department of Streets of a city has a budget of $1,962,800 for resurfacing roads and hiring additional workers this year. The cost of resurfacing a mile of two-lane road is $84,000. The average starting salary of a worker in this department is $36,000 a year. Write the equation that represents the relationship between miles of two-lane roads. The department can resurface X and the number of new workers it could hire Y if it spends the entire budget. So we know right here, guys, the total is $1,962,800. We know that a road, okay, that the 1 mile costs $84,000. We know that a worker, the salary, is going to cost $36,000. So now it tells you also, guys, that the department could surface the miles is X, and that the new workers could hire is Y. So let's talk about it. Hey, you took the amount it takes per mile for a road times the amount of miles plus the salary of a worker times the number of workers is going to equal your total. All right. So again, it's that 84,000 plus the 36,000 for a worker, and that's going to equal, guys, the 1,962,800. Okay, that is what it's going to equal. Not the reason it's giving me that is we needed an X there. Okay, there we go. Okay, guys, here is our equation. So now, guys, it's taking what you wrote in the first equation and solve for y. All right, guys, so if I'm going to solve for y, the first thing we're going to do is we're going to move the x over. Okay, move that x over. So now I'm going to get 36,000y equals the 1,962,800 minus 8,400 times the miles that we have. Isolate your variable, and we'll have the amount of workers that we have. Okay, guys, so that's going to be the one. Let's put it in parentheses so that we know 1,962,000. Okay, 800 minus the 84. That's all going to be over the 36,000. Okay, that should be all over that. Okay, and so now that we have that, all right, let's look down here. And oh, I'm sorry, I should have added another 0 there. Not adding my zeros tonight for some reason. And what does that mean, guys? When we look at this, hey, if we're solving for y, remember that's the number of employees. So that would be the number of employees they could hire spending the entire budget. Okay, that's the number of employees they could hire spending the entire budget without knowing how many miles that they're going to have. Okay, so right here, guys, and then when we solve for x, now we're going to solve for x. So we take that equation and we're going to solve for this guy right here. So let's move the 36,000 over. So now I have 84,000 equals 1,962,800 minus 36,000 y. Isolate your variable and divide by 84,000. So even though it says y, we're solving for x, so that's going to be that 1,962,800 minus your 36,000, and we're going to put that all over. And guys, the way we show that on here is we're going to put parentheses. Okay, you can't do it there. 84,000. Alrighty, and that is what we have. Okay, so let's see, make sure that we have everything correct. Very, very good. And I know that this doesn't match up, but guys, if that is our equation, that is what we would write for that equation. Okay, you take your total You would subtract what you had here, okay, what you see there, and that is then, and then we divided for 84,000. The reason it's not showing up is because this says Y, when really that should say X, guys, and this should say Y, and there we go. Okay, so very, very good. And then in this situation, what does the X mean in this situation? Okay, guys, this is the number of miles that you could resurface while spending the entire budget. Okay. So right here, guys, same thing. The city is planning to hire 6 new workers and to use its entire budget. Which equation should you be used to find out how many miles it could resurface? Okay, guys, remember that we're trying to figure out the amount of roads. We know the amount of workers, so what we would use, guys, is we would use this top equation because we're solving for the amount of roads that we should have, and we're plugging in the y. So it should be this one, okay? And the reason why, people, is because it says that x equals. So you want to know that is equaling the amount of miles that you could have. So you want it to say x equals if you know what y is. And we do know what y is. It's 6. Okay. So now, guys, it's asking us, hey, if you know that there's 6 workers, what are you going to use? Okay, so guys, we chose this equation. The x equals 1,962,800 minus 36,000. We know that we're hiring 6 workers, and we're dividing that by 84,000. Okay, so let's use our math here. The first thing that we need to do is take 36,000 times 6, and I get 216,000. So 1,962,800 minus, we said 216,000 all over 84,000. Okay, guys, so now what we want to do is we want to plug this into our calculator. Okay, so I want to take 1,962,800 minus the 21,600. Okay, and so from there, I get this, and I'm going to divide that by our 84,000. All right, and that shows that at most I can do, and let's make sure, guys, I have 23 here. Okay, and let's go ahead and make sure, okay, that I plugged everything in because we do have a lot of zeros, all right? And so just to make sure that we have everything right, let's go ahead and plug it in. 1,962,800. All right, actually, I'm sorry. Let's go ahead and make sure that we did the 36,000 times our 6 correctly. And I did this, and I just wonder if I didn't do, again, 21,600. I bet I did. It's these dang zeros that are getting me, y'all. I'm sorry. 1,962,800 minus our 216,000. Now let's divide that by our 84,000, and we still get the same answer, okay? So that is what we're looking at, is that 20, okay? We're looking in that 20 range to happen, right? So that's going to be the number that we have, okay? So we said 20, and we look here, and it was actually like 20.7952, so 20.79, okay? And we see that that does fall on the line. All right, and so I got a little nervous, and I'm sorry I redid it. I'm just nervous because it gave us a decimal, And I thought, well, that can't be possible, but hey, anything's possible. So we've got 20.79 miles that we can work. There we go. Okay, 18. All right, how many people could we hire if the department is resurfacing 16 miles of road? 16 miles of road. So let's go back to slide 16, and we see this. And guys, if I have that, okay, if I have that, and I want to see here, all right, the amount of X, okay, I want to know the amount of workers that we have now, so I'm going to solve for Y, okay? I'm going to solve for Y. So I'm going to take Y equals that 1,962,800, and I'm going to subtract the 84,000, and I'm going to divide by 36. And I'm leaving this blank, guys, right here because remember, oh, you can't see that, all right, because remember this was the amount of miles that we were going to plug in. All right, so it says that we're resurfacing 16 miles. Okay? So, let's take that 84,000 times 16. All right? So now I'm going to have 1,962,800 minus 1,344,000 and all over, let's go ahead and switch this back for you, sorry about that, all over 36,000. Okay, so we're going to plug this into our equation now and see what we get. So 1,962,800 minus 1,344,000. I get this divided by 36,000. I got 17.118. Now we've got 17. Okay, and you could say 0.11, but it's going to be 17 is the amount of workers. And guys, that is what we would get. Okay? So 17. And really, then that means if you had that, okay, could we hire 16? We look, okay. So if it's over that, the most you can hire then is the 17. Okay, suppose, let's finish these off. Let's not use such big as numbers this time. Let's pick some smaller ones to make it easier for you guys. So suppose you're organizing a party and you have a budget of V dollars for your appetizers. You plan to order V vegetarian rolls starting at 75 cents each and a shrimp rolls at 95 cents each. The equation 75V plus 95 cents of S equals B represents the constraint. Okay? So guys, remember the way that we put this is, all right, again, it is 75 cents for a veggie roll, for a vegetarian spring roll, and it's 95 cents for a shrimp one. And what we know is when we add those together, that's going to give us our total budget. Now we've got to solve for V. So the first thing we're going to do is we're going to subtract the 0.95s from both sides. And so I'm going to get 75 cents for a veggie roll equals our budget minus the spring rolls, or the shrimp rolls, sorry. So now we want to know the number, so then you're going to take whatever you had divided by your 75 cents, and that's going to give you V. So V would equal B minus the 95 cents for a shrimp roll all over 75 cents. Okay, so now we know that it's going to be V equals that B minus 0.95s all over the 0.75. Okay? And it says, when would that be most helpful to use in this equation, guys? That's if you knew, okay, if the number of shrimp rolls is known. That's why. Okay, a school is holding a carnival and hopes to raise $500. Child tickets. Okay, so here, let's do this. All right, so the total, $500. Child tickets are 3. Adult tickets are 5. All right, and if the school sells X child tickets and Y adult tickets, then it's telling us that we're going to use this 3X plus 5Y equals 500. Solve for X. Okay, we want to isolate the variable again, so we're going to start with the 5. We're going to move the 5 over. So now I've got 3X equals 500 minus 5Y. And then I'm going to isolate the X, so I'm going to divide everything by 3. So my final answer is X equals 500 minus 5Y all over 3. Okay? Okay, perfect. And then, guys, explain when it might be helpful to rewrite the equation this way. Again, guys, that's if Y is known. So if the number of adult tickets is known. Okay, guys, that is it. I apologize for the error on the first one and not adding my 1, 0 and having to go back and do that. I apologize, but hopefully you caught that the first time and it wasn't me going back and explaining that. If you have any questions, please reach out to me. Please reach out to your teacher. And with that, hey, have a great lesson and enjoy the rest of your day.